Okay, so let's create a new program, and a new data set also I'll create here. I'll choose a different data set for this algorithm. Okay, check this now. It's very interesting to see this, and the concept that we have talked, all that we'll see here: how to build a tree, how to create a decision tree model. So here I'm having a data set. Let's see this. See, banknotes.csv file is present. You can search for the data on the net also. So what exactly this data is containing? It's a data set of notes, currency notes basically. Now you can see this is the data set containing. See, when the banknotes are checked for fake or not fake. See, there's a machine present. The notes are entered inside the machine. Machine scans that note and identify that whether this note is fake or not. Correct. So the data set is created like that. First of all, they are given some fake notes. They have scanned and they are recorded. 4 image properties recorded: variance, skewness, kurtosis, entropy. They are the image properties. Remember, they are recorded and according their class is told. 0 and 1, 2 classes are there. 0 is the original note class and 1 is the fake note class. Okay, original notes and fake notes. So likewise, thousands of such notes are recorded. Out of it, few notes are original, few notes are fake. Fine. And you can observe that here also. See, if I show you, see, there is no similarity that you see in this data. Can you see this one? Here it contains negative, positive combination. Here also, here also, here also we have 0.3 and then 4.5 something values. And if you go, these are the original notes, and at the end we have fake notes. Almost 1372 rows are there in it. Okay. Here fake notes are there. You can see this. These are the fake notes properties. Here also we have positive, negative combinations are there. This one. But on what basis we can separate, okay, decision tree, or separate that, how 0 and 1 classes, fake and original note, can be separated? On what basis? That we have to define. See that. So originally scanned notes and their data set is created here. Now I want to build a tree so that when next time new note is coming inside this machine, I will identify whether this is fake note or original note. That's what the data set is defining here. These are the 4 image properties which are scanned with the help of the image scanner in the node scanner presented there. Correct? So you can observe that the data is containing 4. This is the outcome variable, output variable, and these 4 are the input variables here. So if you check the shape, 1372 rows and 5 columns are there. Out of it, 1 is the output variable and 4 are the input variables there. Correct. So let's separate them. Class, I'm dropping class and remaining I'm taken in X, and then exact class I'm taking in Y. See, variance, skewness, kurtosis, entropy. Correct? They are taken separated, and in Y also you can see how many classes are there. Y dot value counts. For 0 class we have 762 entries, and class 1 we have 610 entries present in it. Okay, fine. So almost good amount of data is present with us, so it will be easy for us to build the algorithm. But before building algorithm, we have to do the cross validation. You have to split the data into train test format. And one to note here that if you normalize the data, just like in last session we have talked about normalization of data, which is not compulsory here, which is not compulsory normalization, because this algorithm is not getting affected by the magnitude of the data, because at a time only one feature is for splitting. That's not all are used at a time. That's why this algorithm is not sensitive to the magnitude. But if you want to speed up the process, then normalization is okay. That we can use it there. But let's keep that, and directly we'll go for cross validation here. So to do the cross validation, so I'll just import the train test split. Okay, so 75% data will go on training set and 25% data will go on testing set. Okay, so I splitted it, and if you see the length of this X train data, (1029) entries are there in training. Okay, and for testing 343 entries are there. Okay, so we'll be building a tree on 1029 rows only, and we'll be testing on 343 rows only. Let's create the tree now. So here the class is decision tree classifier. Decision tree classifier. Let's create it. CLF is equal to, yeah, here we have to mention the criterion. Sorry, criterion, that is entropy. Two criteria are there, Gini index and entropy. Gini index is the impurity, means how much error it is having. So where less error is, that will be chosen. For entropy, where high information gain is there, that is chosen. Random set is 0. Decision tree classifier object is created. Now it's present in tree sub package. I'm using the classifier. And now let's train the algorithm. Fit on X train and Y train. Yes, decision tree classifier is created. The tree building process is completed. Training is done. Tree is created now. And now what we will do? What we have done? We have mixed the data randomly. 75% data only we have used, and 25% data is still remaining, which is unknown to the algorithm. Now I will apply that input, that is test input, to the algorithm, and then we will predict some output variables from this. With the help of a tree we can build it. So that's what we can do. Ypred is equal to CLF dot predict X test. On the test data, 343 are there. I'm testing, and same 343 results will be generated. Ypred, that's the output variable that we get. So Ypred is predicted by algorithm, and Ytest, which is already data set is having with us, which is unknown to the algorithm. Now we will be comparing Ypred and Ytest, and then we can see how many entries are matched and how many are not matched. So I'll just show you a result here in a data frame format. Well, we have actual values in the data set, that is Y test, and predicted by algorithm is Ypred. See, actual 1 1 0 0 1 1 0 0 1 1 0. Okay, whatever snapshot is shown over here, they are matching. So that's good. But here the data is truncated in between, but that data we haven't seen yet. We'll see this one also, which is not present in, and data is randomly selected. So it's a mixed combination of 0 and 1 together. Fine. This one. Okay. So actual and predicted. Just two data we have combined and we stored that in the result format here, and you can see. But remember, so I think we have seen the confusion matrix also. Confusion matrix is a measurement of classification criteria. With the help of confusion matrix, it's possible to see how many entries are matched in 0, how many are matched in 1, and how many are mismatched. So let's see that. Y test and Y pred. Yes, see this, it's great. Only 7 mismatches are there. See, 195 entries are there. See, I'll just show you Y test count. See, 195 entries are there for 0 in the test data. Out of it, 190 are matching with 0, means 0, 0 matching. 0 actual, 0 predicted. The algorithm are matching 190 times. And 5, 0 predicted as 1. Okay. And here 148 entries are there. Out of it, again 146 are matching and 2 are predicted as 0. This one entry are predicted as 0 2 times. That's what means 7 entries are mismatching. Here, out of 343, 7 are mismatching, means 336 are perfectly matching. This is the accuracy, 97.95, almost 98% entries are matching correctly here. Okay, so 336 are matching out of 343, 97.95 and 98% almost accuracy is there. Even there is one more method that we can see the complete classification of the data. This is called as classification report. See, in metrics again we can see that. See this. Here 195 entries are the test data set for class 0, and for class 1 148 are there, correct? See, individual class accuracy, out of 195, 97% data is matching for class 0, and out of 148, 99% data is matching for class 1. See, that is recall we call. Recall is there. And precision we call it as like, see here in the predicted data, out of 192, 190 are matching, and out of 151 here, 146 are matching. That is called as precision. 99% and 97% precision that we have, correct? And F1 score is the harmonic mean of both, means almost average of both. This one, if you average them, you'll have this number. This one, harmonic mean is there, and this is the accuracy. And if you want to check accuracy separately, accuracy score, .9795 means 97.95, same, which I calculated by using this formula. How many are matching? How many is this algorithm is perfect for 98% time. Remember, see, for testing data, training data may be the 100% there. Testing data is 98% is accurate. And few things to note that, see, I have chosen the criteria of entropy. Likewise, I can choose the criteria of information gain, Gini index also. Here you have to mention that, here Gini. But maybe no much difference is there. Now same but it was 5 plus 2, now it is 4 plus 3. 7 mismatches are there, but accuracy is same again. We got this balance now using Gini index. It's okay, no problem. And accuracy is same that we can get. Okay, so see, without normalization, we got 98% accuracy. It's not required to normalize the data. Correct. Because at the time only one feature is chosen for the splits. And see, one concept I told about it is feature importance. See, in the classifier, there is a concept called a feature importances. See, the feature importance of respective features are taken. I'll show you the plot of it. Let's have a bar plot, and in bar plot, on x-axis will have the feature names, column names, and on y side will have the feature importances. Correct. Now you can see the bar plot of them. See, this is the feature importance graph. See which feature is important from decision tree point of view. Variance is highest preferable. Its importance is 60, above 60%, 62%. Skewness 0.2. Cutoff is 1 point something. Entropy 0 point something. See, sequentially they are mentioned. Feature importances. So which feature is highly important, that is considered here. So this is also one of the method chosen to identify the feature importances. Feature selection. So feature selection is automatically done in the decision tree. We don't have to specify anything. And how exactly tree is created, that also we can check, but there are some special packages we require. Okay, with the help of that packages only it's possible to perform the operations of it. I'll show you how to create that one. So we have done these all splitting, we have performed the operations, we got the confusion matrix, and now see, just a minute. Yes, let's have a plot. Okay, so from 6, there's a concept called a string IO that I am import. Okay, image we required, then export graph is also required. Yes, and one more I require, import py dot plus. Yes, correct. Then create the object of string IO. Okay, then let's use the export graphies function. Export graphies, in that we can specify a classifier, CLF. Okay, for which is you have to create that. Then we will require the out file, whose name is given above dot data. Okay, then we require, that's our field means colorful graph we require. Then do we require the rounded rectangle? Yes, true. Then do we have special characters? Yes, true. Then class names, 2 classes are there, correct. For 0 class it is original, and for class 2 it is fake. Okay, and is there anything required? Yes, feature names. Wait a minute. Feature names are columns. Yes, see, so export graph is a method which is to create this graph. Classifier, this which is mentioned above, that's chosen. Then out file, this is a dot data file we basically require, field equal to true, rounded true, special character true, class names, which are the class names. 0 is original, 1 is fake. And features means what are the 4 features names are variance, skewness, cutoff, entropy, which are there in the data set. So from x dot columns are taken that, correct. And then we'll create a graph. Graph is equal to I dot plus dot graph from dot data. Okay, so here we require to use this dot data file dot get value. Yes, graph will be created. Yes, and now let's use graph dot write png png use tree dot png. Yes, so this tree will be created. Yeah, the tree is created now. I'll show the tree so you can check it out. These all parameters are required. Accordingly, the tree will be generated in the plot, and the data which are shown there, for that data, how the tree is created, which features are chosen, at what level, what trees will be looking like. See this one. I'll show you the tree which is created from that. The tree, I use this method, write png, to store the tree in the png file. Okay, so that tree will be stored in file in the current working directory. And now you can observe this tree which is created here for actual data. See how big the tree is. See, this is a tree created from the given data. Correct. And see how many levels? 1, 2, 3, 4, 5, 6, 7, 8 levels are there. Check this. Total samples, see here it's created. Total samples are 1029 used for training data. Correct. The first feature chosen, variance. Okay. Gini index is 0.495. You can use entropy also. This is created on Gini index. Okay. So 274 samples 1000. Out of it, 0 is 569 and the high is 462. So where is high values are there? Class is shown here. Higher values are original data, original note. Then the condition is true on this side. Condition is false, will go on this side. Come below. Out of this 1029, 495 are here and 554 are here. In conditional matching on the right side and the remaining are left side. Sorry, left side and right side of it. Correct. 495 are going here. Out of 495, again 90 plus 405 is there, and for 534, 477 to 57 are there. And then here skewness is used. Then here kurtosis is used. Fine, and check it. Again variance is used here. Now Gini has become 0. So when this value becomes 0, stop. The note is fake here and note is original here. Here fake, original. Gini is 0. See. Gini is error actually, and entropy is information gain. See, fake, original, and at the leaf node we are having the whole data. I think 100% accuracy. Eh? Here 0 to 45, 0 3, 1 0, 0 90, 0 10, 0 43, 2 0, 14 0, 0 1. Okay, here also 0 6, 2 0, 5 0, 0 1, 80 0, 4 0, 2 12 0, like all. See, this is how the tree is created. Starting from the root node, we have traversed through all, and at the end we got the leaf nodes with the perfect data. Even the colors I just shown the field equal to, the meaning is that the colors will be shown to you. So the color which is let's say it's an orange color, brown, maybe orange and brown, showing original note, and the blue color is showing the fake notes, where the domination of blue, the fake node is there. It is shown in that color combination. It's called a heat map basically. Colors, see in the root node also you can see some brownish color is there. It means that original nodes are more in the original data, and then it's coming below. Where high intensity is there, that class is defined. You can observe that where these fake nodes are there. This one blue, they are the fake node predictions, and they are the original nodes. This one, they are shown in the orange or this brown color. This is a tree created on the given set of data. By using this method, we can follow, we can perform operation, practically with the help of Python and scikit-learn library. Now let's continue with our presentation and just talk about few more topics about the same. Yes. Yeah. So there's a concept called as hypothesis space search in the decision tree. See, what is that? As per the Tom Mitchell's book, so machine learning book is there. Inside that he has mentioned this particular concept. For example, consider the space for hypothesis that could be in principle be output by above checkers learner. Checkers learner example we have seen in the ID well closed machine learning problem. Checkers was there, and checkers was the first ever machine learning algorithm created in 1956. Like now, in that, the hypothesis space consists of all evaluation functions that can be represented by some choices of value for the weight W0 to W6, for example. So, the learner's task is thus to search through this vast space to locate the hypothesis that is most consistent with the available training examples. Most consistent with the available training examples. So, hence, basically, all possible combinations of distinct trees make the hypothesis space. Distinct trees, all possible. That's what is hypothesis space. Remember. Now, let's say if you have chosen to represent your function to be linear line, then all possible linear lines which go through the data given an input output makes your hypothesis space. Correct. But talking with the decision tree, each tree is single hypothesis that says this tree shall best fit my data and predict the correct results. Best fit my data and predict the correct results from the same. Therefore, combination of all such trees is called as hypothesis space for the given tree over there. So we have seen that. See, this is how many distinct decision trees with n Boolean attributes are possible. How n Boolean attributes? So it's equal to number of Boolean functions, number of distinct truth tables with 2 raised to n rows equal to 2 raised to 2 raised to n. Remember, how many trees are possible then? Hypothesis space. So with 6 Boolean attributes. Boolean attribute talking about where true and false are there. 6. So 2 raised to 2 raised to 6. Check it. This number is there. This number of trees are possible when you have 6 attributes present there. This is called as the hypothesis space for the decision tree. Fine. Remember that. This is what hypothesis space is, and we have seen the example of it. See this. Some trees which you have created. All these example I mentioned presentation also. We have talked about that practically also. Okay, this is what we got finally. And we have visualized the tree also in this way. Correct. Now, let's come with the second. But before proceeding, we'll just take a break of 3 minutes, and after that, we will continue it. Thank you. Welcome back and let's continue. So in the previous session, we have talked about the classification trees, but decision tree can be regression also. They can be used in the regression format also. So trees are divided into classification and regression trees. Regression trees are needed when response variable is numeric or continuous, that case. And classification trees, the name implies, are used to separate data set into classes belonging to the response variable. Now see, cart we call it classification and regression trees that we call. So classification trees and regression trees, two different kind of trees can be created using decision trees here. See how classification trees are created. We perform a split. Let's see. For example, here x1 is the first feature, x2 is second feature. We have done the first split here, this one, to separate these classes. Okay, then second split here to separate this and this. Then third split here to separate all of this and these two, and then fourth split here. Correct. This is your decision trees. Which one? Classification trees are there, which you do on splitting the classes, and accordingly one class, second class, third, fourth can be separated. And here we can see two classes are there, but based on these splits, green class is here also and here also, or the blue class here, here. Like we do the split and accordingly the tree is created, as we have already seen in the classification format. Now regression. So this is what classification, and accordingly tree will be created. See, x1, x2 is greater than 60, yes or no. Then another split here, yes or no. Then another split, then another. So this is the data which is shown over here. That's what tree is created here. The red class and the green class. So two green classes are there. One is here generated, and three red classes are there. 1, 2, and 3. When you do the fourth split, then the last class, which is what we call as less than 20 here, will come here only when we are having less than 70 and less than 60. X1 is less than 70 here, sorry, greater than 70, and this also less than 70, and then again less than 20. Fine. Now this is a classification. Let's see regression trees. Now see, regression trees created like that. In the regression trees, see in this example which is shown here, output variable is in the form of continuous values. Input variable are continuous also. See, for example, x1 and x2 are here. So these splits are done. First of all, we have done this split where two different kind of planes we got. Then second split here, then third split, then fourth split, and now we got 5 planes. All the data present here, they are having outcome variable 65.7. This side 300.5, this side 1023, this side minus 64.1, here 0.7. Correct. So we are doing split, and we create a group of this data separately in this particular format, and everyone is having one expected outcome present from them. So outcome of all of this data is same. All of this data is same, all this same, but they are not in class. They are in the continuous value format. They are called as regression trees. See, now the tree will be like that. See, if x1 is less than 20, yes. Then x2 is less than 200, yes. Then it is 300, and if greater than, it is 65.7. Okay, which is, we can see over here, these two. The first split that we have done. In that again, two splits are there. For 65.7 is different, 300.5 is different. Then for split to above and below is there. Split to above 1023, okay, but below again one more split is there. Correct. Okay, so this is the criteria that we applied, and based on that the regression tree is created, whose all the nodes are different. One node is not duplicated. Every node is different. Just like example we have seen classification, they are duplicated, but in regression they are not duplicated. They are having same continuous values in the nodes, terminal nodes of the trees, called as regression trees. Now see a small example of regression tree, how they are created, what method that we can use to create the regression tree here. Okay, so then we'll finish with the decision tree algorithm. Just check it out. have one data set also with us, and that data set is a data set for non-linear regression. There is no linearity present over here. Remember, non-linear regression. Maybe such kind of problems cannot be solved with the help of the linear regression. So we can apply the decision tree regression in that cases. See the example. I'll show you. The data set is containing petrol consumption of different states. Basically, petrol taxes given, average income, paved highways, population, driver license. Okay, a minute. Talk about the first few entries, and finally, petrol consumption is given. Petrol consumption is this one. You can check it. 541, 524, 561, 414, 410. So there is no any class present here. So based on all of this, four petrol tax, average income, paved highways, population, driver license, we are generating the outcome variable petrol consumption, which is this one. Okay, correct. That exactly. So when you have to build a tree, this will be a regression tree presented from that. Okay, and regression tree will be created with the help of it. You can see the nodes of them are having different specific values. It's not a fixed class. Every node will have a different value. Based on this data, it will be created. Fine, and we can make use of the methods like the mean absolute error to find the average error present between the predicted and actual values. Let's see how to do this one. So before proceeding, we'll just do the splitting of the data, which you had done previously also. Same method I'll apply. I'll check total 48. Sorry, just a minute. We'll petrol consumption. Just a minute. I think yes, P is capital. Yes, they are separated. You can see the shape of it. Total 48 rows and 48 rows and 4 columns are there in it. We'll split that data X and Y in train test format. So I think 36 entries will go in training data, and on that 36 entries only a regression tree will be created. So let's create this. Regression. Ready? But for regression trees, the criteria is not the same. It is used for MAC, that is mean absolute mean squared error. But we will not use that. I'll just use random state here, 0. And let's create this regressor dot fit X train and Y train. So it is fitted, perfect. And now remaining 12 entries are there for which I can predict the values. So Y pred is equal to reg dot predict on X test, correct, predicted. And let's have a result. We'll combine them. Original value and predicted by algorithms values are there that we will predict. See this. So I just combine actual, that is Y test, and we'll have a predicted values is Y pred. And let's check the result, the actual and predicted. Small difference is there in between them, actual value and predicted values. Ready? Okay. So it's predicted by. So here actual value 534. We are getting 541 over here. 410, 498, 477, 628. Small difference is there. So you can identify the mean absolute error between these two values. So let's have that. Okay, so the difference between Y test and Y pred, this is what we are having error presented here, and np.abs absolute error is this for all, and mean absolute error is this. 68.08. Mean absolute error means the petrol consumption generated by the algorithm is having 68 difference, 68 plus or minus. Difference is there that we can see here. Fine. So whatever original data that we have, we can find the percentage of error also. See, if you just check the mean of Y test, it is 543.25. Okay, and if you want to find the percentage error present here, divided by into 100, 12% error is there. If you compare that error with the mean of test data, so error is 12.53%. You can observe it. See what I done: average error, mean absolute error divided by average of test data into 100. So I got the percentage error, 12.53% error is there. If you compare, average error is there if you compare the test data set. 63 value is 12% of mean of Y test data. That's what we are getting the result over here. It is 12.53. Correct. Ready? So this is the idea of using the decision tree regression. And if you want to see the regression tree, I'll use the same code above. But here classes are not there. That's why maybe class names I have to set there. Here I'll use reg. Sorry, before that I need to create the object of string again. Use this object. Then here the classes are not there. That's why I'll not use these classes. Feature names are okay. That are perfectly done. You can find this code in the presentation. When I'm sharing presentations, inside that these codes are already present, so you can use these codes from that if you wish to perform the things practically. And finally the tree is created. It's a regression tree now. Yes, tree. Yeah, true. See this. The tree is created now, and the tree will be something like this. You can see this now, regression tree, which is created for using decision tree regression. How the splitting is done, and accordingly the tree is created. That we can see there. So just check it out. The only 36 entries are there, and for that 36 entries, the tree is created here. Okay, where the difference between the tree generated using classifier and regression is that classification trees contain only fixed number of nodes, multiple nodes, but similar classes are there. But for regression tree, see this, the regression tree. First of all, population driver license less than 0.6. MSC, that is mean squared error, is there, that is calculated, which is where less error is present, that will be chosen. Samples 36, value 587, 36 samples, out of which 32 here, 4 here, again from 4, 3 here, 1 here, 3 here, values completed, that is 968. See, everywhere the nodes are different. 865, 782, 540, 524, 525, 457, 460, 464, 415, 512, 498, 464, 561, 560, like all. See, below, average income, paved highways, petrol tax, all they are chosen, and based on that you can see the trees, regression trees created, where the output variable is in the regression format there. Fine, are you getting it? So you can try that one. And if you just check the feature importances here, again same criteria applicable to regression trees also. The thing that we have seen here, the feature importances, which features are important from the regression there, that we can see x dot columns and reg dot feature importances. See, so highest important feature is population driver license, this one. Then we are having average income, second, third is petrol tax, and fourth is paved highways. This is very less important. Fine, feature importances, which we can see for the regression kind of algorithm also. So this is the common method that we used to follow to create the regression kind of